February 23, 1942. Dravo Corporation Shipyard, Neville Island, Pennsylvania. The acetylene torch hisses blue-white in the pre-dawn darkness, throwing shadows across the steel plate as welding superintendent Frank Morrison watches the bead crack open for the third time in an hour. Ice crystals form on the Allegheny River 40 feet below the slipway, and Morrison's breath clouds the freezing air as he kills the torch and pulls up his welding hood. The plate 3/4 of an inch thick, high-tensile steel meant for the bow section of something the Navy is calling an LST splits along the weld line like rotten wood. "That's the last of the electrodes from the Philadelphia batch," says Morrison's assistant, Jimmy Kozak, stamping his feet against the cold. His 22, fresh from a farm in western Pennsylvania, one of 3,000 workers Dravo has hired in the past 8 weeks. Most of them have never seen a ship, let alone built one. Same problem. Brittle as glass. Morrison runs a gloved hand along the crack, feeling the molecular failure underneath. He's been welding for 17 years, bridges, mostly, and some petroleum tanks during the Depression, but this is different. The Navy wants him to weld together a ship that's 328 feet long, can carry 30 Sherman tanks, and draws only 3 feet of water. A ship with a flat bottom and a bow that opens like a clamshell. A ship that needs to be built in a place that's 2,000 miles from the nearest ocean. And they want it in 4 months. "Get me Captain Harrison," Morrison says, straightening up. "We can't make the deadline with conventional methods. Not even close." The problem is bigger than anyone in Washington wants to admit. 6 weeks ago, in early January 1942, the Allies held a conference Arcadia. They called it, where Roosevelt and Churchill agreed that winning this war meant landing armies on hostile beaches. North Africa, Sicily, France. The Japanese-held islands of the Pacific. Every single one of these operations requires ships that can carry tanks, trucks, and artillery directly onto a beach, lower a ramp, and drive the vehicles off into combat. The British have been trying to build such vessels. They call them landing ships. But their shipyards are being bombed nightly by the Luftwaffe, and their production capacity is stretched to the breaking point, keeping destroyers and corvettes in the Atlantic. In January, the British sent the United States detailed plans for their LST Mark II design, along with a request that shocks even the most optimistic American planners. They need 200 of these vessels. Immediately. Admiral Howard Vickery, vice chairman of the U.S. Maritime Commission, knows the number is actually much higher. His staff has run the calculations. If America is going to fight a 2-ocean war, and the losses at Pearl Harbor 2 months ago mean there's no other choice, they need to move entire armies across water and put them ashore on beaches that have no ports, no docks, no infrastructure. The Pacific theater alone will require hundreds of amphibious vessels. Add the planned invasions of Europe, and the real number is closer to 1,000 ships. Traditional American shipyards are already operating at capacity, building destroyers, cargo vessels, and Liberty ships. The big coastal yards, Newport News, Bath Ironworks, Mare Island, have no spare slipways. Every keel they lay down means one less escort carrier or cruiser. Vickery needs to find a way to build LSTs without using resources already committed to other critical vessels. His solution is radical. Build them inland. At 9 a.m. that same morning, Vickery stands in a conference room in the Navy Department building in Washington, facing a wall map of the United States stuck with colored pins. Each pin represents a potential shipyard, places that have never built an ocean-going vessel, places that are nowhere near the ocean. Dravo Corporation in Pittsburgh. American Bridge Company in Ambridge, Pennsylvania. Chicago Bridge and Iron Company. Inland yards along the Mississippi, the Ohio, the Missouri rivers. The British design calls for riveted construction, says Commander John Niedermayer, spreading the LST blueprints across the conference table. He's a naval architect, pulled from his posting at the Philadelphia Navy Yard to oversee what everyone is already calling the LST program. Every traditional shipyard in America uses riveting. It's proven. It's reliable. But it's also slow. Niedermayer places a finger on one of the blueprint sections. A single LST requires approximately 2 million rivets. At peacetime production rates, with experienced riveters working in optimal conditions, you're looking at 10 to 12 months per vessel. We don't have 10 months. The North Africa invasion is scheduled for November. "What about welding?" asks Vickery. His thinking about the Liberty ships, the emergency cargo vessels being produced at a breakneck pace using all-welded construction. Henry Kaiser's Richmond yards are launching one every 2 weeks. Welding has its own problems, Niedermayer replies. The British tried it with earlier landing craft designs. The welds crack. High tensile steel at those thicknesses, exposed to salt water, flexing under load. Conventional welding rod produces joints that fail under stress. There's also the training problem. How do you teach thousands of workers, farm boys, factory workers, women who've never touched welding equipment to make structural welds that will hold up in combat conditions? Back in Pittsburgh, Frank Morrison has reached the same conclusion through direct experience. By noon on February 23, he's in the office of George Travis, Dravo's chief engineer, explaining why they can't meet the Navy contract using standard procedures. The electrodes are wrong, Morrison says, laying out a welded test plate that's fractured in 3 places. These rods are formulated for structural steel at normal thicknesses. The LST calls for 3/4-inch plate in most places, 1 inch at stress points. When you put that much heat into that much metal that quickly, the cooling rate creates internal stresses. The weld bead cracks. Even when it doesn't crack immediately, it weakens over time. Travis studies the fracture patterns. He's a bridge company man, like Morrison, spent his career building spans across rivers. Ships are new territory. What do we need? New electrodes. Lower hydrogen content. Different flux composition. And we need to change the welding sequence, preheat the plates, control the cooling rate, use a specific bead pattern that distributes stress. Morrison pulls out a sketch he's been working on. I've been talking to metallurgists at Carnegie Tech. They think they can formulate a rod that'll work, but it'll take testing. Weeks of testing. We have 9 weeks until the first hull section is due, Travis says. The Navy is already breathing down our neck. Then we'd better move fast, Morrison replies. What follows is a cascade of urgent telephone calls, express deliveries, and round-the-clock experimentation. Carnegie Institute of Technology's Metallurgy Department starts testing electrode formulations on March 2. Morrison and his team weld test plates, stress them, freeze them, heat them, load them to failure. They discover that preheating the base metal to 200 degrees Fahrenheit before welding reduces cracking by 60%. They learn that a specific sequence welding from the center of the plate outward, alternating sides to balance thermal stress, produces joints that can withstand 3 times the rated load. By March 15, they have a welding procedure that works. But procedure isn't enough. They need to teach it to 3,000 workers who've never welded before. Morrison sets up a training school in a converted warehouse. The curriculum is brutally simple. 12 days of intensive practice, 8 hours a day, welding the same joint over and over until muscle memory takes over. Students who can't master the technique wash out. Those who succeed move directly to the slipway, where the first LST, designated LST-1, is beginning to take shape. The ship emerges in pieces. That's the other revolution Dravo and the other inland yards are pioneering: modular construction. Traditional shipbuilding starts with a keel and builds upward in a carefully sequenced process, each frame and plate going into place in a specific order. There's no time for that approach now. Instead, the LST is broken down into prefabricated sections, built separately in different parts of the yard, then brought together and welded into place. The bow section, that massive clamshell door that will open on beaches from Normandy to Okinawa, is assembled in Building 7, complete with its hydraulic operating gear. The stern section, with the twin screws and rudders, takes shape in Building 9. The tank deck, a long flat expanse designed to carry 30-ton Sherman tanks, is constructed as a series of modules that interlock like pieces of a puzzle. It's a construction technique borrowed from bridge building, from skyscraper construction, from the assembly line logic of Detroit automobile factories. It's not traditional shipbuilding, but it's fast. On March 28, John Niedermayer arrives in Pittsburgh for an inspection tour. He walks the length of Slipway 3, where LST-1's hull sections are being positioned for final welding. Around him, sparks cascade in the afternoon light as 200 welders work simultaneously, joining the modules into a coherent whole. The noise is deafening: the hammer of rivet guns from an adjacent merchant ship, the roar of cutting torches, the electric crackle of arc welders, the clang of steel plates being moved by overhead cranes. How many LSTs can you build here? Niedermeyer asks Travis. Travis looks down at the slipway, calculating. We have 4 slipways that can handle vessels this size. If we can perfect the modular construction technique, optimize the welding sequences, and keep the steel deliveries flowing, say 1 vessel every 3 weeks per slipway. Maybe better. That's not enough, Niedermeyer says quietly. We need more yards. More slipways. We need to scale this up by an order of magnitude. Then you'll need to solve the navigation problem, Travis responds. He points north, toward where the Allegheny and Monongahela rivers join to form the Ohio. These ships are being built 2,000 miles from the ocean. They're too big to go through most locks. They draw too much water for normal river navigation. How exactly are you planning to get them to the sea? Niedermeyer has been studying that problem for weeks. The answer involves dredging operations on the Mississippi, temporary dams to raise water levels, coordinated lock openings at precise times, and pilots who will have to navigate these flat-bottomed, shallow-draft vessels down winding rivers at speeds that barely exceed walking pace. Some of the vessels will take 3 weeks just to reach the Gulf of Mexico. But that's a problem for later. Right now, in late March 1942, the immediate challenge is proving that these inland yards can actually build ocean-going warships using techniques that didn't exist 6 months ago. LST-1 splashes into the Allegheny River on June 7, 1942. From first steel to launch, 105 days. The vessel isn't pretty. Its flat bottom and blunt bow give it all the hydrodynamic grace of a brick. Sailors will later joke that LST stands for Large Slow Target. But when Frank Morrison watches the vessel settle into the water, riding at exactly the 3-foot draft the specifications demanded, he knows they've accomplished something that will change the course of the war. They've built a ship in a place where ships don't get built, using techniques that didn't exist when they started, in a time frame that traditional shipbuilders said was impossible. And now they need to build 1,000 more. July 14, 1942. Missouri Valley Bridge and Iron Company, Evansville, Indiana. The telegram from Washington arrives at 7:15 a.m., and plant manager Robert Hayes reads it 3 times before he believes what it's asking. The Navy wants Missouri Valley to convert its entire operation. A company that has spent 30 years building bridges and water tanks into a shipyard capable of producing 1 LST every 10 days. They want the first keel laid by August 1st. They want the first launch by November. And they're sending a technical team from Dravo Corporation to show Hayes's workers how to do it. Hayes walks out onto the shop floor, where the morning shift is fabricating approach spans for a highway bridge in Kentucky. The building is 800 feet long, equipped with overhead cranes capable of lifting 40-ton loads, and opens directly onto the Ohio River. It has everything needed to build ships except workers who know how to build ships. Shut down the Kentucky bridge fabrication, Hayes tells his foreman, Carl Dietrich. We're about to become the Navy's newest shipyard. What happens in Evansville over the next 6 weeks is being replicated at inland sites across America. The Dravo Corporation isn't just building LSTs in Pittsburgh, they're re-licensing their welding procedures, their modular construction techniques, their prefabrication methods to every company with river access and heavy fabrication capability. It's an unprecedented transfer of technical knowledge, driven by the brutal arithmetic of amphibious warfare. Admiral Vickery's staff has refined their calculations. The North Africa invasion will require at least 200 LSTs. The planned assault on Sicily will need another 100. The eventual invasion of France, still being called Operation Roundup in the summer of 1942, though it will evolve into something much larger, will demand hundreds more. The Pacific Theater, where island-hopping campaigns are being planned against Japanese positions from the Solomons to the Philippines, will consume every LST the Navy can produce. The Maritime Commission identifies 23 potential inland construction sites. By August 1942, contracts are being signed with companies that have never built anything that floats. American Bridge Company in Ambridge, Pennsylvania. Chicago Bridge and Iron. Bethlehem Steel's Hingham Shipyard in Massachusetts. The list grows weekly. Frank Morrison arrives in Evansville on July 20th with 2 assistants and a trunk full of technical manuals. He's been on the road for 3 weeks, moving from yard to yard, teaching the welding gospel according to Dravo. At Missouri Valley, he finds a workforce of 1,200 men, mostly bridge workers and structural iron workers, assembled in the main fabrication building. "You're going to learn to weld in 9 days, Morrison tells them, his voice carrying across the cavernous space. "Not 9 weeks. Not 9 months. 9 days. Some of you won't make it. That's fine. We'll find something else for you to do. But those of you who can hold a torch steady and follow instructions are going to help build ships that will win this war." The compressed training schedule is born of desperation. There's no time for traditional apprenticeships, no room for the careful, years-long progression from helper to journeyman to master craftsman. Morrison and his instructors set up 20 welding stations along one wall of the fabrication building. Students spend 2 days learning how to strike an arc without burning through the plate. 2 days practicing straight beads on flat stock. 2 days on the specific joint configurations used in LST construction T-joints, lap joints, but welds on 3/4-inch plate. 1 day on vertical and overhead welding. 1 day on the preheating and sequencing procedures that prevent cracking. 1 day of testing. Out of 1,200 workers, 847 passed the basic welding certification by July 29th. "It's not enough," Hayes tells Morrison. "We need at least 1,000 welders per shift if we're going to maintain production." "Then hire women," Morrison replies. The suggestion isn't radical anymore, not in the summer of 1942, though it would have been unthinkable a year earlier. In Richmond, California, Henry Kaiser's shipyards are already employing thousands of women in welding positions. At the Boeing plant in Seattle, women are riveting B-17 fuselages. The manpower or woman power is available. The question is whether management will use it. Missouri Valley places help-wanted advertisements in the Evansville Courier on August 1st, women wanted for defense work. Welding training provided. $1.20 per hour starting wage. 372 women show up for the first training session. Among them is Ruth Kowalski, age 26, a former schoolteacher from nearby Henderson, Kentucky. She's never held a welding torch, never worked in heavy industry, but her husband is serving with the 1st Marine Division in the Pacific, and the newspapers are full of stories about defeats at Wake Island and Bataan. "I figured I could either sit at home worrying," she'll say years later, "or I could do something that might help bring him home." Morrison assigns Kowalski to one of the new training stations. The instructor is a bridge welder named Ted Novak, who's been doing this for 20 years and isn't sure women can handle the physical demands. "Welding rod weighs about a pound," he tells the assembled women. "Doesn't sound like much until you've held it steady for 8 hours straight. The welding helmet weighs 3 pounds. The torch gets hot. The sparks burn right through your clothes if you're not careful. And you'll be working overhead, welding joints above your head with molten metal dripping down. You sure you want to do this?" Every hand stays up. By August 15th, Missouri Valley has 1,200 certified welders working 3 shifts around the clock. The first LST keel, LST 157, goes down on Slipway 1 on August 3rd. The modular sections begin taking shape in different parts of the yard: bow section in Bay A, stern assembly in Bay C, tank deck modules in the long assembly building. The prefabrication process is being refined with each vessel. At Dravo, where LST-1 has been followed by LST-2, LST-3, and LST-4 in rapid succession, engineers have broken the construction down into 93 major modules, each of which can be built independently and then lifted into position by crane. The innovation cuts assembly time by 40%. But new problems emerge as production scales up. The steel supply chain is the first major constraint. Each LST requires 1,400 tons of plate steel, not the thin sheet metal used in Liberty ships, but heavy structural plate in specific dimensions. The steel mills in Pittsburgh, Gary, and Youngstown are already running at maximum capacity, producing armor plate for tanks, hull plate for destroyers, and structural steel for aircraft carriers. The Maritime Commission assigns priority ratings, AA1, for the most critical programs. LST production gets an AA1 rating in September 1942, putting it ahead of almost every other steel consumer in America except escort carriers and submarines. Steel mills start running dedicated product lines for LST plate, rolling the specific thicknesses and dimensions the modular construction requires. The river transportation problem proves more complex. LST-1 makes its first journey from Pittsburgh to the Gulf of Mexico in July 1942, and the trip reveals every weakness in the inland waterway system. The vessel runs aground twice in the Ohio River where peacetime dredging has left the channel too shallow. It has to wait 3 days at the lock and dam number 41 for water levels to rise enough to pass through. The pilot, a civilian riverboat captain named Henry Welsh, discovers that the LST's flat bottom and shallow draft make it almost impossible to steer in any kind of current. It's like trying to drive a barn door downstream, Welsh reports to naval officers in New Orleans. The slightest crosswind pushes you sideways. The rudders don't have enough bite in shallow water. And when you try to reverse the engines, the prop wash just churns up mud. Doesn't slow you down worth a damn. The Army Corps of Engineers launches an emergency dredging program on the Ohio and Mississippi rivers. Dredges work around the clock from Pittsburgh to New Orleans, deepening channels, widening bends, removing snags and sandbars. Lock masters receive instructions to hold water levels at maximum safe levels whenever LSTs are in transit. The Navy establishes a special navigation school in Pittsburgh where civilian riverboat pilots learn the peculiarities of handling LSTs in confined waters. Despite these challenges, the vessels keep coming. LST-1 reaches New Orleans on July 26 and proceeds under its own power to the Gulf of Mexico, where it undergoes final fitting out at the Algiers Naval Station. LST-2 follows 2 weeks later. By the end of August, 6 LSTs are navigating the inland waterways toward the sea. At the Chicago Bridge and Iron Company shipyard in Seneca, Illinois, on the Illinois River, a different approach is being tested. The yard is building LST hulls in sections, then floating them downstream as incomplete vessels. No engines, no superstructure, just the basic hull with the tank deck installed. The incomplete vessels draw only 18 inches of water, shallow enough to navigate almost any channel. They're towed to a fitting-out yard in New Orleans, where engines, weapons, and electronics are installed. The partial completion approach cuts construction time at the inland yards by 3 weeks per vessel. By September, most of the inland yards adopt it. They focus on what they do best: welding steel plate into hull shapes and leave the complex mechanical and electrical work to yards with more experience. In Washington, Admiral Vickery tracks production on a wall chart that looks like a steeply rising graph. In July, 4 LSTs launched. August, 11 LSTs, September, 19 LSTs. The curve is exponential, driven by learning effects as workers get faster, as procedures get refined, as bottlenecks get eliminated. But it's still not fast enough. The British 8th Army is fighting Rummel at El Alamein in Egypt. Intelligence reports indicate the Germans are reinforcing North Africa. The planned November invasion operation Torch requires 200 LSTs to land American troops at Casablanca, Iran, and Algiers. As of September 15, only 31 LSTs are fully operational. On September 23, Vickery calls an emergency conference at the Navy Department building. Representatives from every LST construction yard attend, along with Maritime Commission officials, Steel Company executives, and Army Corps of Engineers officers responsible for river navigation. "Gentlemen," Vickery says without preamble, "we're behind schedule. Operation Torch launches in 7 weeks. The British have committed to providing their Mark II LSTs, but they can only spare 43 vessels. That leaves us 126 vessels short of what the operation requires. We need to accelerate production immediately." John Niedermeyer, now a full commander and de facto head of the LST program, presents the constraints. Steel deliveries are meeting targets. Worker training is adequate. The bottleneck is slipway availability and construction time. We're currently averaging 63 days from keel laying to launch at the fastest yards. We need to cut that to 45 days. Can it be done? Vickery asks. George Travis from Dravo stands. We can do 45 days, maybe less, if we go to full modular construction, build the entire ship in sections ashore, then assemble it on the slipway in 1 week. But it requires more fabrication space, more cranes, more preheating equipment. And it requires perfect coordination. One delayed module holds up the entire assembly. How long to implement? We can start testing the approach immediately. Full implementation across all yards 30 days. You have 20 days, Vickery says. Make it work. What follows is the most intensive production engineering effort of the American war economy. At Dravo, Morrison and Travis redesign the entire construction process. Instead of 93 modules, they break the LST down into 247 subassemblies, each small enough to be built at a dedicated workstation, each designed to mate with its neighbors through precisely machined interfaces. The bow section becomes 15 separate modules: the port bow plate, the starboard bow plate, the ramp mechanism frame, the hydraulic gear housing, the bow door hinges, each built separately and then welded together. The tank deck is divided into 24 sections, each one exactly 40 feet long, each one including its deck plating, structural supports, and ventilation trunking. The sections are built on jigs that ensure perfect dimensional accuracy. If the measurements are off by even half an inch, the modules won't fit together during final assembly. The approach is pure mass production, the same logic Henry Ford applied to automobiles in 1913. Break a complex product down into simple, repeatable tasks. Build each component to precise specifications. Train workers to do one job perfectly rather than many jobs adequately. Assemble everything at the end. By October 10th, Dravo launches LST-13 just 38 days after laying its keel. Missouri Valley launches LST-157 41 days after keel laying. Chicago Bridge and Iron hits 39 days for LST-282. The vessels pour into the water like an industrial flood. October production. 34 LSTs launched. The first vessels from the accelerated production run begin arriving at fitting-out yards in New Orleans, Mobile, and Evansville. Crews are assembled, trained in 10-day shakedown courses that teach them how to operate these strange, flat-bottomed ships. Most of the crews have never been to sea before. They're learning to be sailors the same way the shipyard workers learn to be welders: fast, under pressure, with no margin for error. On October 28th, the British tanker SS Fort Royal arrives in New Orleans carrying the engines, pumps, and generators for 18 LSTs. The equipment has been manufactured in Britain and shipped across the U-boat-infested Atlantic because American manufacturing capacity can't produce specialized marine equipment fast enough. The fitting-out yards work around the clock installing the British machinery into American-built hulls. LST-27 completes its shakedown cruise in the Gulf of Mexico on November 3rd. The vessel performs acceptably. The flat bottom makes it roll like a pig in any kind of sea, and the maximum speed of 12 knots makes it painfully slow. But the bow doors work, the tank deck can carry the rated load, and the shallow draft means it can beach itself on almost any coastline. 5 days later, on November 8th, Operation Torch begins. Allied forces land at 3 sites along the North African coast. The assault uses 243 landing ships and landing craft of various types. Only 49 of them are LSTs, 36 British Mark IIS and 13 American vessels that made the transatlantic crossing in October. It's nowhere near the 200 LSTs the operation was supposed to have. But it's enough. The landings succeed. American troops are ashore in North Africa, beginning the long campaign that will drive across the Mediterranean and eventually up the spine of Italy. And back in the inland shipyards of America, the LSTs keep coming off the slipways, one after another, an assembly line armada built in places where ships don't belong, welded together using techniques invented 6 months earlier by men and women who are making it up as they go along. January 19, 1943. Dravo Corporation Shipyard, Neville Island, Pennsylvania. The thermometer outside Frank Morrison's office reads 8 degrees Fahrenheit, but on Slipway 2, where LST 468 is being assembled, the temperature hovers near 90 degrees from the concentrated heat of 340 welders working simultaneously. Morrison watches from the observation platform as the starboard hull section, a 180-foot-long, 40-ton module, swings through the air suspended from the yard's largest crane. Below, a crew of 40 riggers guides the massive piece into position, aligning bolt holes that must match within 1/16 of an inch. "Mark!" shouts the assembly foreman, and the crane operator, a woman named Dorothy Chen, who learned her trade 3 months ago, lowers the section with precision that would have taken a veteran crane operator years to master. The bolt holes align. Riggers slam temporary bolts through the connections. Within minutes, welders are swarming over the joint, their torches igniting in a cascade of sparks. Morrison checks his stopwatch. The entire operation, from crane hook-on to first weld, has taken 11 minutes. 6 months ago, the same operation required 3 hours. This is what industrial learning looks like. Every vessel built teaches lessons that make the next vessel faster, better, cheaper. The welding procedures that took weeks to develop in March 1942 are now taught in standardized 9-day courses. The modular construction techniques that seemed radical in the summer are now routine. The jigs and fixtures that ensure precise dimensional control have been refined through 18 iterations, each one cutting assembly time and reducing errors. Dravo is now launching one LST every 6 days. The yard operates 3 shifts, 24 hours a day, 7 days a week. Steel arrives by rail from Pittsburgh mills at precisely scheduled intervals. Modules move through the fabrication bays on a carefully choreographed schedule that resembles nothing so much as an automobile assembly line, except the product weighs 4,000 tons and will carry tanks into combat on beaches from Sicily to Saipan. But the acceleration comes with costs. Morrison has seen quality start to slip as yards prioritize speed over precision. Welds that would have been rejected in August are being accepted in January because rejecting them means missing production targets. Some vessels are leaving the yards with minor defects: misaligned deck plates, improperly sealed bulkheads, welds that don't meet full penetration standards but are good enough. Good enough is a dangerous standard in naval architecture, and Morrison knows it. But the pressure from Washington is relentless. The Navy needs LSTs for Operation Husker invasion of Sicily scheduled for July 1943. They need LSTs for the Pacific, where Admiral Chester Nimitz is planning a campaign through the Gilbert and Marshall Islands. They need LSTs for the eventual invasion of France, still more than a year away but already consuming planning attention. Every week without an LST means a week's delay in operations, means ships that could have been landing troops on enemy beaches are instead unbuilt steel sitting in Pittsburgh warehouses. The arithmetic is brutal and inescapable. On January 27, Morrison receives a telegram from the Bureau of Ships in Washington. Quality control concerns noted: stop inspect LST 471 prior to river transit, stop report findings immediately. LST 471 is one of Missouri Valley's vessels, built in Evansville under the accelerated 45-day schedule. Morrison takes a train to Indiana, arriving on January 29 to find the vessel tied up at the fitting-out dock, visibly listing 3 degrees to port. The list itself isn't dangerous. LSTs are designed to operate at various trim angles, but it's a symptom of something wrong. Morrison spends 2 days crawling through LST 471's interior with a team of inspectors. They find 37 cracked welds in the tank deck structure, 12 improperly sealed hull penetrations, and a bow door hydraulic system that's been installed backwards. None of the defects are immediately catastrophic, but taken together, they represent a vessel that was rushed through production without adequate quality control. How did this pass inspection? Morrison asks Robert Hayes, Missouri Valley's plant manager. Hayes looks exhausted. He's been running the yard on 4 hours of sleep a night for 6 months. We're launching one vessel every 8 days, he says. We have inspectors, but they can't check every weld on every vessel. We're doing statistical sampling, check 10% of the welds, assume the rest are good. It works most of the time. Most of the time isn't good enough when you're putting sailors into combat, Morrison replies. The inspection of LST 471 triggers a comprehensive review of quality control procedures across all inland yards. The Maritime Commission sends technical teams to every facility, conducting spot inspections, reviewing welding procedures, testing randomly selected joints to destruction. What they find is disturbing. Approximately 18% of vessels show quality defects serious enough to require rework. The problem isn't the welding procedures themselves; those work when properly followed. The problem is human error under pressure. Welders skipping the preheat step to save time. Inspectors signing off on welds they haven't actually examined because they're behind schedule. Supervisors who know about defects but don't report them because stopping production means explaining the delay to admirals in Washington. John Niedermeyer, now coordinating LST production from the Navy Department, implements a new quality control regime in February 1943. Every vessel must undergo a pressure test before leaving the inland yard. The tank deck is sealed and pressurized to 3 pounds per square inch, and inspectors look for leaks. Every major weld must be X-rayed or magnafluxed to detect internal cracks. Any vessel that fails inspection is held at the yard, regardless of production schedule impacts. The new procedures slow production temporarily. February launches drop to 28 vessels, down from 34 in January. But the vessels that do launch are sound, and the rework rate drops to less than 5%. In the yards, workers adapt. At the American Bridge Company facility in Ambridge, Pennsylvania, shift supervisor Helen Kowalska-Ruther's sister-in-law, recruited into defense work after her husband deployed to North Africa, implements a peer review system among welders. Every weld is checked by a second welder before the inspector sees it. Workers whose welds consistently pass inspection get recognition and small bonuses. Those whose work requires frequent rework get additional training. Pride of workmanship, Kowalski tells her shift at a February morning meeting. Every weld you make, imagine it's the one that's going to keep your son or brother or husband alive when he's landing on a beach under fire. Because it might be. These ships aren't just steel, they're life preservers for the men who'll sail them. The message resonates. Rework rates on Kowalski's shift drop to less than 2%. The Maritime Commission circulates her peer review system to other yards as a best practice. By March 1943, the production system has found its rhythm. The inland yards have become something that didn't exist in American industry before: a distributed shipbuilding network, building identical vessels to identical specifications at sites scattered across 1,500 miles of American heartland. Steel flows from Pittsburgh and Gary. Engines arrive from General Motors and Electromotive. Weapons come from arsenals in Rock Island and Watervliet. Everything converges at the assembly yards, where the components are welded into vessels that slide into rivers and begin the long journey to the sea. The scale is staggering. In March alone, 43 LSTs are launched. In April, 51. The vessels pour down the Ohio River in convoys, sometimes 6 or 8 at a time, guided by pilots who have become expert at handling these unwieldy craft. At New Orleans, the fitting out yards work around the clock installing equipment, loading supplies, training crews. Lieutenant Commander Arthur Jenkins receives command of LST 389 on April 12, 1943. He's 28 years old, a 1937 Naval Academy graduate who spent his first 5 years in the Navy on destroyers. The LST is his first command, and he regards the vessel with a mixture of pride and skepticism common among professional naval officers assigned to these ungainly ships. "She's not pretty," Jenkins tells his executive officer, Lieutenant Paul Bronson, as they tour the vessel during its final fitting out in New Orleans. "But she'll do the job." LST 389's crew is typical of the type: 117 men, most of them reservists with minimal sea time, a handful of regular Navy petty officers to provide experienced leadership. The average age is 22. Many of them are from inland states Iowa, Kansas, Nebraska, and saw the ocean for the first time when they reported to New Orleans for assignment. They learned their trade during a 10-day shakedown cruise in the Gulf of Mexico. Jenkins beaches the vessel repeatedly, running the bow onto the sand at Ship Island, lowering the ramp, backing off with the stern anchors. The crew practices loading and unloading trucks from the tank deck, learns how to balance the vessel's trim by pumping ballast water between tanks, discovers how the flat bottom makes the ship roll sickeningly in even moderate seas. Seasickness pills, Bronson advises the crew. Take them early and often. This ship will make you puke in weather that wouldn't bother a rowboat. On April 25, LST 389 departs New Orleans as part of a convoy heading for the Mediterranean. The vessel carries 35 trucks, 12 bulldozers, 6,000 gallons of aviation gasoline in drums, 40 tons of ammunition, and 200 replacement troops for units already fighting in North Africa. The cargo is typical. LSTs have become the workhorses of American logistics, carrying everything from tanks to typewriters, from plasma to pontoon bridges. The Atlantic crossing takes 18 days. The convoy averages 8 knots, limited by the LST's maximum speed. German U-boats are still active in the Atlantic, though the tide is turning as improved convoy tactics and long-range patrol aircraft exact an increasing toll on the submarine fleet. The convoy experiences one submarine alarm sonar contact that turns out to be a whale but otherwise makes the crossing without incident. LST 389 arrives at Oran, Algeria, on May 13 and immediately begins discharge operations. The bow doors open, the ramp lowers onto the beach, and trucks roll off into North Africa. The entire discharge takes 6 hours. By evening, the vessel is empty, riding high in the water, ready for its next assignment. That assignment comes quickly. The invasion of Sicily Operation Husky is scheduled for July 10, and the build-up of forces in North Africa requires a constant stream of supplies. LST 389 makes 3 round trips between Norfolk, Virginia, and Iran in May and June, carrying tanks, trucks, artillery, and troops. On each voyage, Jenkins gains confidence in his strange vessel. The LST handles poorly in rough weather and rolls like a log, but it's sturdy, reliable, and can put cargo directly onto a beach without requiring port facilities. Back in the United States, production reaches its peak. May 1943, 57 LSTs launched. June, 63. The inland yards are operating with mechanical precision, each one a factory that happens to produce ships instead of automobiles or refrigerators. At Dravo, the construction time has been cut to 33 days from keel laying to launch. At Missouri Valley, the record is 31 days. At Chicago Bridge and Iron, 29 days. The workers have become expert at tasks that didn't exist a year ago. Dorothy Chen, the crane operator at Dravo, can position a 40-ton hull section to within a quarter-inch on the first try. Ruth Kowalski, the former schoolteacher now welding at Missouri Valley, can lay a perfect bead on 3/4-inch plate overhead while sparks shower down onto her protective gear. The riggers, the fitters, the inspectors, the electricians, all of them have developed skills through sheer repetition, through building the same vessel over and over until every operation is instinctive. Frank Morrison, traveling from yard to yard as the Maritime Commission's roving troubleshooter, sees what has been accomplished and is simultaneously proud and troubled. Proud because American industry has done something unprecedented, built 1,000 ocean-going vessels in places that had never built ships, using workers who had never seen a ship, in a time frame that traditional shipbuilders said was impossible. Troubled because he knows the costs, the marriages strained by round-the-clock shift work, the injuries from industrial accidents, the workers who collapsed from exhaustion and had to be replaced. On June 28, Morrison is back at Dravo, watching LST 534 slide down the ways. It's the yard's 102nd LST, and the launch has become routine enough that most workers don't even pause to watch. The vessel hits the water with a tremendous splash, settles at its designed waterline, and is immediately taken in tow by a harbor tug that will position it at the fitting-out dock. 33 days, 2 hours, 16 minutes, George Travis says, checking his records. New yard record. How many more? Morrison asks. The contract runs through December. At current rates, we'll deliver another 75 vessels. Maybe 80 if we can maintain the pace. Morrison does the arithmetic in his head. Dravo alone will build nearly 180 LSTs. Missouri Valley will build 171. Chicago Bridge and Iron, 104. American Bridge, 119. Add in the other yards Bethlehem Hingham, Jeffersonville Boat and Machine Works, the smaller facilities along the Mississippi, and the total approaches 1,100 vessels. From 0 to 1,100 in 18 months. From an industrial sector that didn't exist to the world's largest producer of amphibious assault ships. From workers who couldn't weld to welders who could build ocean-going vessels in 30 days. It's a transformation born of necessity, driven by war, enabled by American industrial capacity and the willingness of thousands of ordinary people to learn new skills under crushing pressure. The LSTs aren't elegant vessels. They'll never be confused with the graceful cruisers and destroyers that traditional shipyards produce. But they work. And in July 1943, when Operation Husky begins and Allied forces storm the beaches of Sicily, it's the LSTs that make the landing possible, delivering tanks to the beaches at Gela, trucks to the shores at Licata, artillery to the landing zones at Syracuse. LST 389, under Arthur Jenkins's command, beaches at Gela on July 10 at 2:45 hours, its bow doors opening under fire from German shore batteries. The vessel disgorges 18 Sherman tanks in 14 minutes, then backs off the beach and returns to sea, its hull scarred by machine gun fire but structurally intact. Jenkins will make 2 more runs that day, bringing ammunition and reinforcements to the troops fighting inland. By nightfall on July 10, Allied forces have landed 80,000 troops, 7,000 vehicles, and 300 tanks on Sicily's beaches. More than 200 LSTs participate in the operation, American vessels and British vessels, working together to put an army ashore on hostile coast. The invasion succeeds. Sicily falls. Italy teeters toward collapse. And in the shipyards of the American heartland, The workers who made it possible continue their routine. Cut steel, weld plate, assemble modules, launch vessels, repeat. The war still has 2 years to run. The invasion of France is being planned. The Pacific campaigns will require hundreds more amphibious vessels. There's no time to celebrate, no pause to reflect on what has been accomplished. There are only more LSTs to build, more modules to weld, more vessels to launch into rivers that will carry them to the sea and into history. June 6, 1944. 6:30 hours. Omaha Beach, Normandy, France. LST-342 grinds onto the sand with a shudder that runs through its entire frame, the flat bottom scraping over submerged obstacles that the German defenders have spent months installing. Lieutenant James Wardlaw, commanding from the con on the upper deck, watches through the smoke and spray as the bow doors begin their hydraulic swing open. Ahead, through the grey morning light, Omaha Beach is a nightmare of fire machine gun tracers stitching the surf, mortar rounds detonating among the landing craft, the bodies of soldiers floating in the shallow water. Ramp down! Wardlaw shouts into the voice tube, and below, in the tank deck, Chief Boatswain's mate Marcus Henderson throws the lever that lowers the steel ramp onto French soil. 14 M4 Sherman tanks, their engines roaring, lurch forward into water that's still 3 feet deep. Henderson watches them go, counting 1, 2, 3, making sure each tank clears before the next one moves. This is the 5th beach landing he's made in 18 months, starting with Sicily, then Salerno, then Anzio. He knows the drill. The first tank makes it 20 yards before a German 88mm round punches through its turret. The second tank veers left, seeking cover behind a beach obstacle. The third tank's engine dies in the water-flooded intake, Henderson thinks, and it sits there, immobile, blocking the path. Get that tank moving or get it out of the way. Henderson bellows at the crew, but his voice is lost in the cacophony of battle. He signals to the LST's deck crew, and they run a tow cable to the disabled tank, dragging it sideways so the remaining vehicles can pass. By 7 o'clock, LST-342 is empty and backing off the beach, its stern anchors digging into the sand as the twin screws churn in reverse. Wardlaw counts 3 shell holes in the hull, none below the waterline, thank God, and 1 smashed ventilator on the upper deck. 1 crewman wounded, hit by shrapnel while working the bow winch. Not bad, considering. Wardlaw takes the LST back to the transport area 5 miles offshore, where it will reload from the cargo ships and make another run to the beach. Around him, the largest amphibious operation in history is unfolding. 156,000 troops landing on 5 beaches, supported by 1,213 warships and 4,126 landing craft of all types. More than 230 LSTs are participating in Operation Neptune, the amphibious phase of Operation Overlord, and every one of them is a vessel that was built by workers in places like Pittsburgh, Evansville, and Seneca, Illinois. Workers who never saw the ocean. Workers who learned to weld in 9 days and build ships in 30. Frank Morrison isn't at Normandy. He's back in Pittsburgh on June 6, working the morning shift at Dravo, where LST 906 is being assembled on Slipway 3. He learns about the invasion when someone turns on a radio in the welding shop, and Walter Cronkite's voice crackles through static, describing the beaches, the paratroopers, the massive armada. Morrison stops welding and listens, imagining the vessels he helped build now grinding onto those beaches, their bow doors opening, their crews doing what they were trained to do. Later, Morrison will learn that of the 230 LSTs at Normandy, 19 were damaged by enemy action, 3 were sunk, and 208 completed their missions and returned for subsequent trips. The survival rate more than 90% validates every decision made in 1942 and 1943. The welding procedures that prevent cracks, the modular construction that speeds repairs, the simplified design that makes the vessels robust even when operated by inexperienced crews. But on June 6, Morrison doesn't know the statistics. He only knows that men are fighting on French beaches, and the ships carrying them were built by people like Ruth Kowalski and Dorothy Chen and Helen Kowalski and the thousands of other workers who transformed themselves from farmhands and schoolteachers into shipbuilders. By June 1944, LST production has become so routine that it barely makes news. The inland yards have launched more than 800 vessels. The learning curve has flattened. There are no more dramatic improvements in construction time, no more revolutionary changes in technique. Dravo still builds LSTs in 32 to 34 days. Missouri Valley averages 35. The system works, and it keeps working, day after day, shift after shift. The Maritime Commission begins planning to wind down production. The Navy's requirement for LSTs is finite 1051 vessels, according to the latest calculations. By July 1944, more than 900 have been completed or are under construction. The remaining vessels will come off the slipways through the fall and winter, and then the program will end. At Missouri Valley, plant manager Robert Hayes starts thinking about reconversion, how to transform his workforce back to building bridges and water tanks once the war ends. At Dravo, George Travis is already negotiating contracts for post-war commercial vessel construction. The workers in the yards know the end is coming. Some will keep their jobs in the peacetime economy. Others will return to farms or schools or wherever they came from before the war. The temporary emergency that mobilized them is becoming less temporary, less urgent, as Allied victory becomes increasingly certain. But the war isn't over yet. In the Pacific, Admiral Nimitz' island hopping campaign is consuming LSTs at a steady rate. The invasion of Saipan in June 1944 uses 73 LSTs. The Philippines campaign, beginning in October 1944, will require more than 100. And as American forces drive westward toward Japan, every island assault Iwo Jima, Okinawa demands more amphibious vessels. LST-534, the vessel Frank Morrison watched launch from Dravo in June 1943, arrives at Iwo Jima on February 19, 1945, as part of the initial assault wave. The island's black volcanic sand provides poor traction for the LST's flat bottom, and the vessel struggles to maintain position as it disgorges its cargo of trucks and artillery. Japanese artillery fire from Mount Suribachi pounds the beach, and LST-534 takes a near miss that buckles 3 hull plates and kills 2 crewmen. The vessel limps away from the beach and makes it to a repair ship, where Navy welders, some of them trained using the same procedures Frank Morrison developed in 1942, patch the damaged hull. LST-534 returns to service 3 days later. By April 1945, the last LST rolls down the slipways. LST-1152 launches from Chicago Bridge and Iron on April 3. The program is complete, 1,051 vessels built in 31 months. The total exceeds the combined tonnage of the entire U.S. Navy at the start of World War I. It represents 4.2 million tons of welded steel, fabricated by a workforce that grew from zero to more than 75,000 at peak production. The final accounting will show that inland yards built 964 of the 1,051 LSTs. The remaining 87 came from coastal yards. The inland construction program, the radical idea of building ocean-going vessels in places with no ocean access, proved not just feasible but superior to traditional approaches. The modular construction techniques, the simplified designs, the standardized procedures all contributed to a production miracle that changed naval warfare forever. Frank Morrison retires from Dravo Corporation in 1946. He's 47 years old, his health damaged by years of working in welding fumes and industrial environments. He'll live another 32 years, long enough to see his grandchildren graduate from college, long enough to read histories of World War II that describe the LST program as one of the great industrial achievements of the 20th century. In those histories, he'll read about his contribution, though rarely by name. The historians will write about American industrial capacity and remarkable production achievements and the arsenal of democracy. They'll note that LSTs participated in every major amphibious operation from 1943 through 1945. Sicily, Salerno, Anzio, Normandy, southern France, Iwo Jima, Okinawa, and dozens of smaller operations in the Pacific. They'll record that LSTs carried 1.3 million troops, 3.2 million tons of supplies, and more than 60,000 vehicles into combat. What the histories won't fully capture is the human dimension: the former schoolteacher who became a welder, the crane operator who learned her trade in 3 weeks, the plant managers who reinvented shipbuilding under impossible deadlines. The histories will note that LST construction required new welding techniques, without explaining that those techniques were developed through trial and error by men like Morrison, working through frozen Pennsylvania nights, testing weld after weld until they found procedures that worked. The LSTs themselves mostly disappear after the war. Some are sold to foreign navies. Others are converted to commercial service ferryboats, cargo haulers, even a few that become floating restaurants. Many are simply scrapped, their steel recycled into peacetime products. By the 1960s, fewer than 100 LSTs remain in service anywhere in the world. But their impact endures. The modular construction techniques pioneered for LST production influence post-war shipbuilding worldwide. The welding procedures developed in Pittsburgh become industry standards. The concept of distributed manufacturing building complex products at multiple sites using standardized components becomes a foundation of modern industrial practice. And somewhere in every textbook on project management, in every case study of rapid industrial mobilization, the LST program appears as an example of what's possible when necessity meets capability, when ordinary people are asked to do extraordinary things, and when they succeed beyond anyone's expectations. Dorothy Chen, Ruth Kowalski, Helen Kowalski, Robert Hayes, George Travis, Arthur Jenkins, James Wardlaw, Marcus Henderson and thousands of others whose names appear in no history books all played their part in building an armada that helped win a war. They worked in places where ships shouldn't be built, using techniques that didn't exist when they started, meeting deadlines that seemed impossible. They welded steel in the American heartland, launched vessels into rivers, and sent them downstream toward battles they would never see. They built 1,051 landing ships in 31 months, and in doing so, they changed the course of history.